1. Question number 2. 20 cm cube of carbon 2 oxide as packed with 20 cm cube of oxygen. CO2, carbon 2 oxide, this is the formula, reacting with oxygen, O2, to give you carbon 4 oxide. If you want to balance this, then there will be 2 here and there will be 2 here. The equation is balance. From the question, volume before sparkling, volume before spark. You have 20 cm cube for carbon 2 oxide, 20 cm cube. You have 20 cm cube of oxygen, 20 cm cube of oxygen. And the volume of this is 0 since it is not given. Reacting volume. Reacting volume. Reacting volume is based on the number of moles of each compound or molecule. 2, 1, 2. Reacting volume for CO, which is carbon 2 oxide, is 20 cm cube. Based on 2:1 ratio, then the reacting volume for oxygen will definitely be 10 cm cube. Then, based on the ratio, the reacting volume for carbon 4 oxide will also be 20 cm cube. Then, volume after spark. Volume after spark will definitely be for 20 cm cube of CO. The volume after sparking will be 20 cm cube. The volume after sparkling for oxygen will definitely be 20 cm cube. Then the volume after sparkling for carbon 4 oxide will definitely be 20 cm cube. So if you look at this very well, what you will discover is that this nullifies this. So you have none left. This, in this, you have 10 cm cube. And this, in this, is 20 cm cube. Therefore, the volume of the residual gas will be 10 cm cube of oxygen plus 20 cm cube of carbon 4 oxide, which is equal to 30 cm cube. Hence, the volume of residual gases after sparkling is 30 cm cube. Question number 3. Determine the vapor densities of the following gases from the given data. A. Sulfur 4 oxide. Sulfur 4 oxide is SO2. Based on the relationship between relative molecular mass and vapor density, it is given that relative molecular mass is equal to 2 times vapor density. Now, what is the relative molecular mass of sulfur 4 oxide? relative molecular mass of sulfur 4 oxide is equal to sulfur is 32 plus 2 atoms of oxygen. Oxygen is 16, so 2 atoms will be 2 into 16. And at the end of the day, you're going to have 32 plus 16 times 2, that is 32. So which is equal to 64. That means the relative molecular mass of sulfur 4 oxide is 64 grams. Now, since relative molecular mass is equal to 2 times vapor density, and the relative molecular mass of sulfur 4 oxide is 64, which is equal to 2 times vapor density. The question asks us to look for the vapor density of sulfur 4 oxide. Automatically, to get vapor density for sulfur 4 oxide, you divide both sides by 2. And when you divide both sides by 2, you will have vapor density is equal to 64 divided by 2, which is now equals to 32. That means vapor density for sulfur 4 oxide is equal to 32. So the answer to question A is 32. Question B, it is given that 560 cm cube of oxygen weighing 0.8 gram at STP, standard temperature pressure. 560 cm cube of oxygen is equal to 0.8 gram at STP. At STP, you have 22400 cm cube of 1 mole of a gas. Automatically, if you want to determine the mass of oxygen at 1 mole of STP, which is equivalent to 22400 cm cube, 22400 cm cube. You don't know the mass of that, the mass of the oxygen. So if you want to determine the mass of the oxygen, you cross multiply this equation. If you cross multiply this equation, you are going to have the mass times 560 is equal to 0.8 times 22400 cm cube. Then the mass will now be equals to 0.8 times 22400 divided by 560. Automatically, if you do your mathematics very well here, you are going to have 32 grams. The mass of oxygen at 1 mole of that gas at STP is 32 grams. Remember earlier that I said relative molecular mass is equal to 2 times vapor density. And since you have determined the relative molecular mass and you are looking for vapor density, automatically you impute this value into this. Then you have 32 equals to 2 times vapor density. Our interest is to look for the vapor density. So looking for the vapor density here, you divide both sides of the equation by 2. So automatically you're going to have vapor density equals to 32 over 2, which is equals to 16. That means the vapor density of oxygen is equal to 16. And this is the answer to question B of 3. Question Number 4. Under the same conditions of temperature and pressure, hydrogen diffuses 8 times as fast as a gas Y. Calculate the relative molecular mass of Y when that of hydrogen is 2. This question, if you look at this question closely, it is based on Graham's law of diffusion, which states that the rate of diffusion of a gas is inversely proportional to the square root of its vapor density. Mathematically, it can be written as the rate of diffusion of a gas is inversely proportional to square root, is inversely proportional to the square root of the vapor density. Can be written this way. Based on the question, we are considering 2 gases here. The first one is hydrogen gas, while the second one is gas Y, unknown gas. Based on that, if I want to rewrite this question, this formulae, it can be rewritten as R for the first gas, Y, unknown, over R for the second gas, which is hydrogen, is equivalent to square roots of the vapor density of